Welcome to my series of AI videos. Uh, Today's video is going to be a little theoretical. Okay, we saw lots of videos on RAG, retrieval augmented generation. Now this is kind of how to scale your RAG system with lots of data. Uh, so let's dive deep in. Okay, so just to recap, what is RAG? Uh, in the RAG, uh, you have some user query, okay, and you kind of augment that user query with proprietary data. Okay, so you have your proprietary data stored in a vector DB. You do a semantic search, okay, and then you augment that user query, original user query, with the context that you get from your proprietary data. Okay, and the main goal or the main reason of doing this is you want to provide the ground truth from the proprietary data to alleviate hallucinations. Okay. Uh, so how do you scale this, right? I mean, you have lots of data, right? Maybe hundreds of thousands of documents, so on and so forth. Okay. So first of all, you organize your knowledge base in a hierarchy, right? So say, for example, it's say lots of news articles you are dealing with. Okay. So the hierarchy here would be like you have news, right, which is organized into categories, right? So I'm picking one category like sports, right? Now the sports would be organized in different sports, right? I'm taking an example of cricket, right? And cricket would have lots of articles, right? Now comes the interesting part of RAG that each article uh, comprises of lots of chunks. Okay, so you kind of have to capture all this hierarchy. Now, what is a chunk? So, chunk is a semantic unit of data. Okay, and one key thing here is it's kind of this hierarchy is bidirectional in a sense that in each lower order uh, element entity you keep the link or a parent ID basically, right? So, like a article on cricket would say what is my parent. Okay. Okay. So the interesting part is this chunk, right? Now, what is the trade-off of chunk size? So if you have too large a chunk, try to dilute a meaning, okay? And the context that you give would be noisy because it will be like a too large, right? Now, what is the downside of too small a chunk, right? So there will be too many chunks, right? And there will be lots of overhead in the system, okay? So you have to kind of look at what is a reasonable size for your chunk, right? So for something like a fixed size chunk, it would be like a 500 bytes, right? Or for documents, it would be like a section of a document. Okay, so that's a typical practical uh, limit on a chunk size. Okay, so when you do this chunking, right, you have to do some sort of a smart chunking, right? So in article, you could have sections, right? And you'll see lots of uh, classes or tools available here, like for PDF document, right? It can break it up at headings, right? Similarly, for a Word document, you can break it at like level one heading, level two heading, so on and so forth, right? So all these tools are available these days, right? So you have to kind of for variety of tools you have to use. For a PDF document, you may have to use a PDF reader and chunk it using the PDF chunking technique. For code, it could be functions, right? So on and so forth. Okay. Now comes the interesting part that these kind of the lowest level of entities in our hierarchy, which is chunk, right? They'll be covered by vector DB, right? But now, how do you deal with this higher level of entities, right? So now, as you can see, these entities are not much in terms of count number, right? Chunks will be lots of chunks, right? But not too many of these. Now for these, what we'll use is we'll use structural index, like a traditional index basically, right? Like, for documents, you could have a document ID as the key and document as the value, right? Similarly, for sections, you could have a section ID and the actual content of that section as the section, right? So on and so forth. Okay. Now, how does our uh, this enhanced retrieval flow looks like, right? You recognize this data like this, right? Now, how do you sort of do this RAG that we saw in the beginning, right? So you get a user query, right? You look up your vector DB. Vector DB gives you the chunks, right? From the chunks, you get the parent ID, right? From that chunk. Now you fetch the hierarchy, right? Now you may walk up these parent IDs depending on where you are in the hierarchy or what query you have, right? And you fetch these entities like a document using a document ID, for example, right? So using these structural indices, you fetch these entities at a higher level in the hierarchy, right? And then from this, maybe you can add a summary, right? So not only you get the relevant chunks for that query, but you get a summary of the documents that these chunks are part of, for example, right? So all this is like domain dependent, okay? uh, then you construct this rich context, right? And this rich context is what you send to LLM. Okay, so this is how you scale your RAG solutions. So if you have liked the video, click the like button, subscribe to my channel, and enjoy building systems with AI. Bye.